Okay, good afternoon. So today's topic is feature extraction. I'm Padmani Mugare from MIT Academy of Engineering. So here, basically, whenever we are extracting a feature of any images, any kind of image or object, there is a like a face. We are trying to extract eyes, nose, cheeks, and chin, such kind of features, right? So before going to extract that feature, we should know about the what is exactly the feature descriptor. So feature descriptor is nothing but to representation of the image or the image patches that specifies the images by extracting the useful information and throwing away the extraneous information. So this is what about a feature descriptor, and here it converts the images of the size of width, height into three the channels to the feature vector array of the length n. In case of Hawk feature descriptor, the input image of the size 64 by 128 by 3 are the and the output feature vector is of the length 3780. So here we have to keep in the mind that the Hawk descriptor can be calculated for the other size, but in the post I'm here the sticking to some number presented in the original paper, so we can easily understand the concept with one of the example. So here the suppose we consider one of the example with the histogram of oriented gradient will be used under the feature descriptor. So Hawk feature descriptor where the distribution with some histograms of direction of the gradient are used as a feature. So here you can see the gradients like x and y derivations, or we are going to derives this x and y, right? So gradients of the images are useful because the magnitude of the gradient is large around the edges and the corner. And here we know that the edges and corner packs in the lots more information about the project shapes than the regions. Some references are given for your informations. Here we can have one image is given, and for that we are going to represent that image with some pixel size 150 by 306 64 by 128 8 by 16. So whenever we are trying to represent the images with some minimum pixels matrix, then image is going to be compressed with that particular size. So histogram, what exactly the histogram? That histogram is one of the important tool in the image processing, and it's nothing but the graphical representation of the distribution of the data. So image histogram gives a graphical representation of the distribution of pixels intensities in the digital images. So x axis indicates the range of values variable which can takes the input, and this range can be divided into a series of interval called as a bins. So y-axis shows the count, how many values fall within that interval or within that bin. So here we are going to plot that histogram. We have a pixel intensity in the x-axis and the frequency in the y-axis. So histogram can be calculated with the both the grayscale images and for the color images. So here the first case, when we consider or we have a single channel, hence single histogram. In second case we have three channel which has three histograms. So it depends on completely on that channel, that how many histogram you wanted to be used. So calculating the histogram of the images is useful, as it gives the intuition regarding some properties of the images, such as a tonal range, contrast, or some brightness of the images. And histogram image or image histogram with some axis representation, that is x-axis representation, different colors values, and lies between the 0 to 225, that is a gray color, and y-axis represents the number of times particular intensity value occurs in the images. So whenever we are going to calculate the histogram, we should consider in the mind that what kind of programming or function under the OpenCV we are going to use. So which is the useful in the which one the useful function in the OpenCV that provides the multiple inputs with images, channels, mask, bins, and the range. So that function is nothing but the uh, uh, calc hist, that is one of the function which we are creating under the OpenCV, and giving input arguments with some images, channel, mask, bins, and the range, where you know that image is nothing but you are going to access one of the image on which you wanted to perform the operation of histogram. Second is a channel, is the index of channel, to consider the wrapped as a list of the grayscale images, as they're only the channel with some zeros and one and two matrix for the color images which wanted to consider the channel green, blue, and the red respectively. Third is nothing but the mask, that which part of image you wanted to mask applied on the images. And if you wanted to consider only specific region, only that specific region will be get masked. Bin is a list of containing a number of bins to use for the each channel. And range is the range of the possible pixel value, which is a 0 to 255, that is in matrix. It can be represented with the 0 to 256 in case of RGB color space. Here the program under the OpenCV that represent to import the OpenCV library with a NumPy, and plot library with the PyPlot, and you can access images with read, IM read, and then calculate the histogram without any mask. So in that case, you are accessing histogram 1, 2, and 3 for 3 channels. So calculate the histogram with for the image with the 0, 1, and 2, red, green, blue, with the pixel value of 0 to 256. So plot that images whatever we have taken for histogram 1, 2, and 3. So histogram subplot of 2 to 1 which represented with that image, subplot of 2 to 2 represented with some images. Okay, so after that you can see how the histogram of that image will be represented with the red, green, and blue channel. So how do the Hawk descriptor work here? That cornerstones of the Hawk descriptor algorithm, which appearance of the object can be modeled by the distribution of intensity gradient inside the rectangular region of the images. So we can see here that Hawk descriptor algorithm, that appearance of that model can be represented with the gradient inside this particular region. Okay, so this is represented with this magnitude and gradient orientation histogram. So how much oriented histogram is there for the given magnitude of the selected pixels of that image. Aspects of how that basically is look at some important aspect of how that makes different from the other feature descriptor, and that focus on the structures structures or the shape of the object, and that also focus how is different from the edge features we extract for the images. And in case of edge features, we only the identify if the pixel is edge or the not. So that is bifurcated from the other features. So Hog is able to provide the edge direction as well, and this is done by extracting the gradient and orientation basically. So additionally, these orientations are calculated in the localized portion, and this means that the complete image is broken down into the smaller region, and for the each region the gradient and orientations are to be calculated. Then and only we can able to extract the feature based on this gradient and orientation whenever we are getting extracting from the given image. How would we generate the histogram for each image region separately at the end? And histograms are created using the gradient and orientation of the pixel values. So here the name histogram of oriented gradient for this algorithm, which is the process of calculating the histogram of oriented gradient for the given image. So here we can consider the image of 180 by 280 pixel, and here we'll see in detail or look at how the hawk features will be created for this images. Okay, so that will be continue in the next video. Okay, so that will explain you that the algorithm of hawk will use to extract the image features. Okay, thank you.